Hello, I'm Ria Patel. So, think what if we need to transmit a signal as per our need? We have such as circuits that do this type of work. In digital electronic, we have mainly two type of circuits. First is the synchronous circuits. Synchronous circuit uses centralized clock. So, as per particular time period, it transmits a signal. But think what if we don't need a signal as per fixed interval of time? Uh, what if we need a signal as per our need? So the best answer is asynchronous circuits. Asynchronous circuits are uses event-driven architecture so that they perform a task as per event occur. What is a asynchronous system? We can say that as like a synchronous system, it not uses global clock or it not based on a centralized control, whereas it uses event-driven architecture and distributed control to transmit a signal. There are many protocol are available like a handshake protocol, reliable protocol are there. But handshake protocol are widely used and known protocol in asynchronous system. So now further, what is the difference between synchronous and asynchronous system? So synchronous system, transmission is faster than asynchronous system because in asynchronous system they have extra bit and gaps. Synchronous system need a centralized clock function or some centralized control to share or to transmit. But whereas asynchronous system is cheap and easy to implement because they don't need any centralized control or clock to transmit a data. In synchronous system, may have to wait briefly until data can be sent, whereas it can in asynchronous system it can transmit when it is ready. All parallel transmission is synchronous, whereas asynchronous transmission is used when data is sent sporadically, for example, via mouse or keyboard. As we are typing something via our keyboard or we are clicking on something, that type of action is held by asynchronous circuits and asynchronous system. My next point is modularity in asynchronous system. It uses object-oriented modules. As we discussed earlier, it not followed by a centralized clock function, or it not follow a certain fixed clock period to transmit a signal. That is the reason it may operated at different speed because it not operated by a global clock. The main advantage is the main advantage of asynchronous system is a low power consumption because it is an event driven system. So it transmit when event occur. Otherwise it stay on in hold mode. As we can see in a picture, synchronous system uses a centralized control via clock function, whereas asynchronous system uses distributed control like a handshaking interface. Furthermore, it also helps to reduce power dissipation in CMOS circuit because get only switch when they are doing a useful work rather than on every clock edge. A speed-independent design is tolerant to variations in a gate speed, but not to propagation delay in a virus. Such an approach enables the design of fully delay insensitive circuit and automatic layout. Now, asynchronous communication. It typically performs on communication system like email, where we need to send and receive data. In a rightmost figure, we can see that in asynchronous system, sender and receiver don't share a common communication line between them. They are using separate communication lines. Sender send the data via email to receiver, and receiver give a reply to that a reply back to that sender. Whereas in synchronous system, sender and receiver share same communication line between them. For example, while we are talking to someone, we share a single communication line between sender and receiver. Now we can see a detailed communication in asynchronous system. Sender send a request and share a data to receiver, and receiver acknowledge back, give a back signal as an acknowledgement to a sender. So a simple channel between typically consists of two wire. A request and acknowledge used for asynchronous communication. Now we see in detail. Now we are looking in a detail of handshaking signals. As we seen in a previous slide, handshaking signal uses two wires. One is for request and one is for acknowledgement. So as we see in this picture, request is initiated with data, and as sender acknowledge that request, it accept that data and give a acknowledgement signal to a sender. Register A, uh, reg- uh, oh, register B, a request for a data to register A. Register A send data and acknowledgement signal to register B. So now, mechanism of handshaking. Source-initiated handshaking consists of two signals. One is for data valid and one is data accepted. If data valid signal is on, it tells that data on databus is valid, otherwise invalid. Data accepted signal. If it's on, then it tells that data is accepted, otherwise not accepted. Now let us understand these signals and process of these signals. Source place data on databus and enable data valid signal. Now destination accept data from the databus and enable data accepted signal. After this, disable data valid signal means data on the databus is invalid now. Disable data accepted signal and the process ends. Now let's have a look on two types of handshaking signals. The two type is four-phase handshaking protocol and two-phase handshaking protocol. In four-phase handshaking protocol, the request is asserted by the sender component, and the receiver responds by asserting the acknowledge, then both signals are deasserted in turn. In two-phase handshaking protocol, the requester simply toggle the value on request wire once, and the receiver respond by toggling the value on the acknowledgement wire. Now we can talk about a two-phase handshaking signal in detail. So, as we discussed earlier, sender request to a receiver with data, and receiver send acknowledgement signal to a sender that acknowledge sender that data has been received by, successfully received by receiver. The other diagram is a timing diagram for sender and receiver's action. In that, the dotted line is shows receiver actions and the constant line shows sender actions. One, after after acknowledgement occur on previous data transfer, receiver is now free to send a new data to a receiver. Sender is ready to send a new data to receiver. Sender request to receiver on a clock edge uh, that the data is ready to be to send. Sender gives on raising clock age. Sender gives acknowledgement to a sender. Receiver gives acknowledgement to a sender that it is ready to receive a data and data has been received. Here is a block diagram of two-phase handshaking signal using Mueller-C element. Now, what is a Mueller-C element? It is simply a small digital block in a digital electronic, which is mainly used to design asynchronous circuits. It it can be made with using flip-flops. The advantage of it is fast and minimal of signaling event and important for global interconnects. And disadvantage is it's sensitive and it has a state. The given figure is illustrate two-phase dual-rail channel. Furthermore, four-phase handshaking protocol. The diagram shows a timing diagram of four-phase handshaking protocol, and the constant line indicates sender action, and the dotted line indicates receiver's action. The receiver request to a receiver request for data to a sender. Sender gives a acknowledgement signal and send the data to a receiver. And then receiver send acknowledgement back to a sender that data has been received successfully. It is a slower but unambiguous process. It also known as RETS. Now, the next point is asynchronous data path. In this figure, we can easily see a difference between synchronous and asynchronous data path. Synchronous data path is depend on clock pulse, whereas asynchronous data path doesn't have any centralized control as a clock. It uses a FIFO, first in, first out mechanism to serve requests. Let's uh, let's have a detail in asynchronous data path. Let's have a detailed look in asynchronous data path. First, event-driven energy consumption. Asynchronous logic implements fine-grained clock gating by automatically turning off unused circuit, since the part of the circuit which do not contribute to the computation have no switching activity. Second is inheritance pipelining. Most programs spend around 90% of their time on configuration that loop, while the remaining 10% is spent in sequential configurations. The asynchronous cell contain latch flip-flop within them. As a result, a certain degree of inheritance pipelining is provided for repetitive executions of data paths. Simple software and hardware design. Average case communication between the array cell is automatically enforced by handshaking irrespective of map data path length. The need of both worst case data path timing estimate the logic to implement clock division and eliminated. Reduce program size. There is no need to save clock information for every configuration step. This achieves further memory saving associated with reduced configuration bit for the pipeline. Now, here this figure shows asynchronous circuit block. Here, sender send the request to receiver 1 to n, and then send the data to receiver 1 to n. In back action, receiver 1 to n sec acknowledge back to a sender. This is a asynchronous sender connect. In conclusion, asynchronous circuits are better to use because they are reliable, low power, lower hardware requirement, better noise immunity, and faster operation. Asynchronous circuit is a better option when we need to get data as per requirement. Thank you.